Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Khalid Al-Harbi and I will be dedicating this presentation to talk about experiment RK5, which is about the neutralization of aqueous solution of acetic acid. Now I apologize for presenting this way, but I was facing technical difficulties while showing the presentation on view mode, so I'm stuck with this option. I apologize for the inconvenience. Now, to outline this presentation, I will start by introducing the topic, then state the objectives of the experiment, then talk about the theory behind the experiment, then show the results and discuss them, and then conclude by showing one sample calculation for one run. Now, as an introduction, the experiment at hand is a good representation for what happens in the body with stomach acid. When the acidity or the pH of the organic acid in the body goes low, the solution would be to take an anti-acid commercial tablet, which is what brings us to the objectives of the experiment. Firstly, we want to test the effectiveness of the commercial antacid tablets, because what the reaction at hand is a very good representation for what happens in the stomach, and also to determine the value of combined mass transfer and kinetic rate constant for the neutralization of aqueous solution of acetic acid. Now, the theory is quite simple. It's as follows: the reaction is given in this equation, in which the hydronium ion is thought of as reactant A and the cation is thought of as reactant B. The design equation of a batch reactor is used because the reaction is supposed to take in a batch reactor. Then the tablets are thought of as disks, which is why the surface area is 2 pi r squared for the two surfaces of the disk, and then 2 pi r h for the edges. The aspect ratio, which is the height over the radius, is alpha, and for simplicity reasons and to ease the calculation, it's thought of to be constant throughout the experiment. Using the alpha, the instantaneous surface area of the tablet would be 2 pi r squared times 1 plus alpha. Now, assuming constant reaction volume, the design equation of the batch reactor comes like this, as follows. For the or in terms of the concentration of A, using the stoichiometry, we can change this into the stoichiometry in terms of reactant B, because the rate of change of moles of A is twice as the change of moles for B, using the stoichiometric equation. Then the design equation becomes like this. Then assuming constant composition for the tablets, we can find NB, or the moles of reactant B, in the following equation. Now, substituting this NB in this equation gives us, and then performing the derivative on NB with respect to dt, gives us the following equation, which can be used in the charts later to find the reaction order and the reaction rate constant, after plotting dr, or minus ln of minus dr over dt versus ln of Ca. Performing an overall material balance on this system, the concentration of A is related to the instantaneous radius by this equation. Then the concentration of A can be found through the definition of the pH. Then the instantaneous radius becomes like this after rearrangement. As for the procedure, now unfortunately, due to COVID-19 crisis, we were unable to perform the experiment ourselves, but the professors were kind enough to provide videos that illustrate the experiment procedure and data analysis in a very decent way. However, to summarize the procedure for this experiment, we start by preparing a 5% acetic acid solution, then use 250 ml in a 500 ml beaker of that 5% acetic acid solution. Place the beaker on a magnetic stirrer, then use or submerge 3 tablets in the beaker for the first part of the experiment, then 5 for the second part of the experiment. We record the pH values for the run in specified time intervals based on the log sheet provided to fill this table. Now, this table, the pH is recorded during the experiment. However, concentration is found, as we said, through the definition of pH, which is minus log of 10 to the power minus the pH, gives you the concentration, and then the instantaneous radius is found using the last experiment or equation. This is done for 3 tablets and 5 tablets. These values were used to construct the tables that will be shown or the charts that will be shown shortly. However, to approximate the rate of change of radius with respect to time, the rate or let's say delta R over delta T is used here. So for example, we will take this this value minus this value and we divide it by this value minus this value for time in seconds, and then tabulate the results in a table. This will or tabulates ln of minus dr over dt times or versus ln of Ca to give a straight line that is best fitted by a line with a slope that is equal to the reaction order, and an intercept that can be used to find the value of k using the following equation. This equation has one unknown only, which is k, that can be used to find the value of k, or the value of the rate, combined mass transfer and rate or kinetic rate constant. Now this is done for 3 tablets and 5 tablets. The sample calculation is very easy, using the definition of pH to find the value of concentration of A, then use the concentration to find the instantaneous radius. Thank you.